all of you to today's class of Pharmaceutical Organic Chemistry. I am Rosalind Mishra, Assistant Professor, ITS College of Pharmacy. Welcome back. We shall continue with our Unit 5 of Pharmaceutical Organic Chemistry, code BP 202T. Okay. So, in today's class, we shall be starting the second part of our Unit 5, which is aliphatic amines. Okay. So, the title of today's class would be Classification and Properties of Amines. As you can see here in the content part, under aliphatic amines, we are supposed to learn in detail about the following topics or the following heads, which is basicity, effect of substituents on basicity of amines, qualitative tests, few structures and uses of derivatives of amines, namely ethanolamine, ethylene diamine and amphetamine. All right. So, let us start our today's class about amines. Amines are organic derivatives of ammonia. Okay. They are organic derivatives of ammonia with one or more alkyl or aryl groups bonded to the nitrogen atom. Okay. So, the nitrogen atom is the center for the amines. It has got one or more than one alkyl group or aryl group, okay, bonded to the nitrogen atom. Next, classification of amines. Talking about the classification of amines, these amines are classified into four major categories. Okay. They are classified into four major categories, namely primary amines, secondary amines, tertiary amines and quaternary amines. Primary amines, secondary amines, tertiary amines and quaternary amines. Okay. Next, here if you see in primary amines, the amine which is NH3, one of the hydrogens in NH3, or if I mention it in this manner, okay. So, in primary amines, one of the hydrogen atom is replaced by an alkyl group, which can be denoted in this manner. Okay. So, instead of NH3, one of the hydrogen atom is replaced by an alkyl or an aryl group, making it a primary amine. Next, when we talk about a secondary amine, when we speak of a secondary amine, then instead of one hydrogen, two hydrogen atoms are replaced. So, you can see here two hydrogen atoms are replaced by alkyl or aryl groups. Similarly, in tertiary amines, three hydrogen atoms are replaced by an alkyl or aryl groups. Okay. So, this is about tertiary amine. Primary amine, structure or general structure of primary amine, general structure of secondary amine, general structure of tertiary amine. Okay. Now, moving on further, let us look into the classification of amines. As we have just discussed, primary amine is the one where one alkyl or aryl group attached to the nitrogen atom. Okay. That is, one of the hydrogen atom is replaced by alkyl or aryl group. Similarly, secondary amines wherein two alkyl or aryl groups are attached to the nitrogen atom. Secondary amine has two alkyl or aryl groups attached to the nitrogen atom. Next, tertiary amine, they have 3 alkyl or aryl groups attached to the nitrogen atom. Moving on towards the quaternary amine, it is an ion in which nitrogen is bonded to 4 alkyl or aryl groups. They bear a positive charge. Okay? They bear a positive charge. Now, moving on towards classification of amines. So, this is, here we can see nitrogen atom at the center, one alkyl group attached, making it primary amine. Okay. Similarly, moving on to secondary amine, nitrogen group at the center replaced by 2 alkyl or aryl groups, forming secondary amine. Here we have the molecular structure. Next we have tertiary amine, wherein one nitrogen atom attached to 3 alkyl and aryl groups. Okay. So, this is about classification of amines. Now, primary amines are formed from the names of the alkyl groups bonded to nitrogen, followed by the suffix amine. Okay. So, how do we name amines? The naming is formed from the names of the alkyl group bonded to the nitrogen atom, followed by suffix amine. The prefixes di, tri and tetra are used to describe 2, 3 or 4 identical substituents. Okay. So, here we have the common names, where the R group denotes the prefix or the main name, which is ethyl, followed by the name amine. Okay. So, here since the R group is an ethyl group, it is named as ethylamine. Similarly, here we have ethyl, the parent name, dimethyl amine. Similarly, this can be named as cyclohexyl dimethyl amine, cyclohexyl parent name, dimethyl prefix counting the number of alkyl groups and followed by amine. Next we have tetrabutyl ammonium chloride, tetrabutyl ammonium chloride. So, these are the few examples of amines and their common names. Moving on to nomenclature of amines. Now, common name and IUPAC name are used extensively for naming of amines. Okay. That is, we use either amines are named by their common names or the nomenclature or the IUPAC names. In the common system, rules similar to what we have seen for ethers are employed. Naming the alkyl or aromatic groups attached to the functional group and then following by amine. As we have discussed in our previous slides, the common naming of amines is done as we do it for any other ethers, okay, wherein the alkyl group is named first, followed by amines. Okay. Here again we have a few examples as we had discussed earlier. Now, moving on towards IUPAC naming system. Okay. Moving on towards IUPAC naming system. The IUPAC for naming system for amines can be briefed as follows. The first step in naming would be select the longest carbon chain bound to the nitrogen as the parent chain. Okay. So, here we will select the longest carbon chain which is bound to the parent chain. The second step will be name the chain by changing the alkane name for this chain, drop the E and add amine. Suppose if we have butane here, if you have the longest chain, if suppose for example is butane, then we name it as butan. We will drop the E. Okay. We will drop the E here. So, we will just name it as butan followed by amine, butan followed by amine. So, the name would be butanamine. Alright. So, under the IUPAC name, first the longest carbon chain is selected, then we give the alkyl name, okay. We drop the E and add amine to it. Next, number the chain to give the nitrogen the lowest numbering. So, the nitrogen atom must achieve the lowest numbering. The number and identity of other substituents including the main chain are indicated at the beginning of the amine. Okay. So, for example, here 2 butanamine, 1 butanamine, which would be correct, as we said the lowest numbering must be given to the nitrogen atom. Okay. So, where amine substituted alcohols or other compounds are present, in such cases involved, the amine group is called as amino substituent. Okay. That is, for example, wherever there is OH group, okay, along with amine, wherever there are alcohol substituted, then amine becomes amino. Okay. For example, 3-amino butanoic acid. Next we will discuss about few physical properties of amines. Talking about the physical properties of amines, amines are gases for low molecular weights compounds. Okay. That is, the low molecular weight amines exist in gaseous state, they exist in the form of gases. Okay. Next, for example, up to CH3 thrice N, up to trimethylamine, amines exist as gases, and many heavier ones, that is above 3, if we talk about, then they exist as liquids at room temperature. Okay. So, the lower amines exist in the form of gases, whereas as we move up higher, they tend to become liquids at room temperature. One very important noticeable thing about amines is that they tend to exhibit very strong odor. Okay. They have got a strong disagreeable odor. For example, fishy smell. Here if we see, these are examples of few amines, namely all known as putrescin, butan, delamines, cadaverin, example 1,5-pentan diamines. These are a few amines which exist as liquid in room temperature. Moving on further, amine boiling points are intermediates of those for alcohols and alkanes of similar molar mass. Okay. So, if we discuss about the boiling point of amines, then amines have a boiling point which lie in between or which lie as intermediate between that of alcohols and that of alkanes. Okay. Because of the presence of amino bond NH bond, due to the presence of NH bonds in primary and secondary amines, hydrogen bonding is sometimes possible. Hydrogen bonding due to the presence of NH bond is seen. This increases the boiling point. Okay. That is, because of the presence of NH bond in primary and secondary amines, hydrogen bonding is sometimes possible. However, because nitrogen is not electronegative as oxygen, the NH bond is not as polar as the OH bond. Okay. Now, let me make one thing clear. This NH bond has the tendency to hydrogen bond with water. Okay. It has the tendency for hydrogen bonding, but the problem which is seen here is the NH bonding. Nitrogen here is less electronegative when compared to oxygen. Nitrogen is less electronegative when compared to oxygen. Hence, the hydrogen bonding capacity of amine is much lesser. Okay. Though it can form a hydrogen bond, but the hydrogen bonding capacity is much lesser when compared to the OH bond. Okay. Hence, weaker hydrogen bonding is seen. Thus, the boiling point is not very high. It lies as an intermediate between other compounds. Here if you see, it does form hydrogen bonding, but the probability is lesser, or the intensity of hydrogen bonding is lesser. Here if you see, the boiling point of primary alcohol is much higher when compared to that of the primary amines of similar molecular weight or similar carbon number. Okay. It is due to the lower electronegative potential of nitrogen when compared to oxygen atom. So, here in this, with the help of this graph, wherein boiling point is compared with carbon number. Okay. So, equal number of carbons in primary alcohol has got much higher boiling point, when compared to the same number of carbon atom containing amines. Now, other physical properties of amines. Apart from boiling point, let us discuss the other physical properties of amines. Amines tend to be water soluble, okay, but due to its weak hydrogen bonding, as we have just discussed in our previous slide, due to its weak hydrogen bonding interaction with water molecule, the water solubility varies. In fact, amines have fewer than 6 carbon atoms. They are infinitely water soluble. Water solubility decreases as the chain length increases. Okay. As the length of chain increases, water solubility as usual decreases. Next, water solubility also depends upon the degree of nitrogen substitution. Okay. So, as primary amine moves towards secondary and tertiary amines, water solubility also decreases accordingly. Next, moving on to discuss the basicity of amines, a very important topic which we are going to delve into. Okay. Now, amines are basic because they possess a pair of unshared electrons. Okay. They contain lone pair of electrons, due to which they have a basic nature or basic characteristics. Next, this lone pair of electron which the nitrogen contain, they can share it with other atoms. These unshared electrons create an electron density around the nitrogen atom. The greater the electron density, the more basic the molecule becomes. Okay. So, this lone pair of electron helps in forming or helps in imparting basicity to the amines. Alright. Now, the greater this electron density, the more or basic the molecule will become. Now, groups that donate or supply electrons to amines will increase the basicity of the amines. Very simple thing, amines contain lone pair of electron which form an electron cloud around the nitrogen atom, thus helping it in donating the electron pair. So, any group which has the tendency to increase this electron density, any functional group which has the tendency to increase this electron density around the nitrogen atom will help in increasing the basicity of the amines. Okay. While the groups which are electron acceptors, or the ones which decrease the basicity of amines or which decrease the electron density around the nitrogen atom, they decrease the basicity of amines. Okay. Very simple. Due to this property of the alkyl group attached to the nitrogen of the amine, the electron density around the nitrogen atom increases, due to which its electron releasing ability increases. Due to the greater and easier release of electrons in the alkyl amine, the molecule becomes more basic than ammonia, whereas in ammonia there is no such electron releasing group. So, obviously, the basicity of ammonia is much lesser when compared to the alkyl amines. So, here with the help of these two pictorial representations, we will be discussing the basicity of ammonia when compared to the primary amine. In ammonia, the nitrogen atom is attached to 4 hydrogen groups. Okay? Whereas, in primary amine, the nitrogen atom is linked to an alkyl group. This alkyl group helps in sharing its electron towards the nitrogen atom, hence increasing the electron density around the nitrogen atom, thus imparting more basicity towards the primary amines. Okay. Hence, primary amines are more basic when compared to ammonia, or alkyl amines are more basic. Next, the basicity of amine in the gas phase and aqueous solutions also vary. Okay. In the gas phase, the order of the base strength can be written as NH3 less than primary amine, which is lesser than secondary amine, which is in turn lesser than tertiary amine. Whereas, in aqueous solution, the order of basicity gets reversed. Okay. That is, increase in basicity can be seen. Next, moving on towards discussing effect of substituents on basicity of amines. This is again a very important topic, effect of substituents on basicity. The basicity of the amines depends on the ability of the lone pair or non-bonding electrons at the nitrogen atom to form bond with an acid. Okay. So, what is the effect when we talk about the effect of substituent? The first thing which we need to understand is the basicity of the amines depends on the ability of the lone pair or the non-bonding electrons at nitrogen atom to form bond with an acid. Okay. The more easier the lone pair electron forms bond with the acid, it will make the amines a stronger base. Okay. More easily the lone pair of electron gets shared with the acid, more basic would be the amine. Very simple. Okay. So, basicity depends upon ability of the unshared electron, or the lone pair of electron to form bond with the acid. Okay. So, basicity can be denoted by that. Easily the more easier the bond gets formed, the more basic is the amine. Next, factors that affect the basicity of the amine can be listed as follows. Substitution by electron donating groups. Okay. The presence of alkyl group or electron donating groups such as CH3, CH2, etc., or ethyl or methyl groups will make the amine more basic, because these are electron donating groups which would help in increasing the electron cloud around the nitrogen atom. For example, methylamine is more basic than ammonia. Other factor is electron withdrawing group. What happens if the amine is substituted by an electron withdrawing group? Well, the presence of electron withdrawing group will decrease the basicity. For example, nitroaniline is less basic than aniline. Next, talking about basicity of aromatic amines. Aromatic amine is less basic than aliphatic amines and ammonia. Why? Because the lone pair of electron on the nitrogen atom is delocalized into the benzene ring. As a result, the lone pair of electron is less available for donation to an acid. Boiling point of amine, as we had already discussed, boiling point and water solubility depends upon hydrogen bonding. The powerful intermolecular attraction that results from OHO hydrogen bonding in alcohol, whereas NHN hydrogen bonding is weaker. So, these are the references of today's class. I hope the class was of use to all of you. Do listen carefully. The topics which we had discussed in today's class are of utmost importance, because here we dealt with the basicity of amines and how various factors affect the basicity of amines. Next class we will move on towards other properties, preparations and chemical reactions of amines. Thank you. Have a good day.